everyone, today I'll be talking about aerospace, and specifically airplanes, but before that, watch this. Paper airplanes and real airplanes follow the same exact rules. Today we're breaking down the four main forces that make flight possible. By the end of this video, you will be able to explain how airplanes fly using four fundamental forces: lift, weight, thrust, and drag. You'll understand how engines create propulsion, how wings generate lift, and why air, something we can't even see, is powerful enough to hold a 400-ton airplane in the sky. So why do we even care about airplanes? Airplanes are one of the most important mechanical engineering achievements in human history. Every time you fly across the country in a few hours, that's physics and engineering working perfectly together. But this isn't just about passenger planes. The same principles apply to fighter jets, drones, cargo planes, and even spacecraft during launch. Understanding how airplanes works helps engineers design faster aircraft, more fuel-efficient engines, and even future electric or hydrogen-powered planes. Every airplane in flight is controlled by four forces. First is weight. Weight is a force of gravity pulling the airplane downward. Second is lift. Lift is the upward force created by the wings pushing against the air. Third is thrust. Thrust is the forward force generated by engines. Fourth is drag. Drag is the air resistance pushing backward against the plane. For an airplane to fly level, lift must be equal to weight and thrust must be equal to drag. If the lift is greater than the weight, the plane climbs, and if the thrust is greater than drag, the plane speeds up. Flight is just a constant balance of the forces. Now, here's the mechanical magic: lift. Airplane wings are shaped like something called an airfoil. The top of the wing is curved and the bottom is flatter. When air moves over the wing, it travels faster over the curved top surface. Faster moving air creates low pressure. Slower moving air below creates higher pressure. That pressure difference pushes the wing upward. But here's something important. The wing also pushes air downwards. And according to Newton's third law, for every action, there's an equal and opposite reaction. The air pushes the wing upward now. So lift comes from pressure differences and Newton's third law. Thrust comes from propulsion systems. In a propeller plane, the propeller spins and pulls air backward, pushing the plane forward. In a jet engine, air is sucked, compressed, mixed with fuel, ignited, and blasted out the back at high speed. That backward blast creates a forward thrust. Again, Newton's third law. Push air backward and the plane moves forward. Without thrust, the plane would slow down because of the drag. But what is drag? Drag is air resistance. As the airplane moves forward, air pushes against it. The faster the plane moves, the more drag it experiences. That's why airplanes are designed to be streamlined. Smooth bodies, swept wings, minimal rough surfaces. Engineers constantly try to reduce drag because less drag means better fuel efficiency, higher speed, less engine power needed. Now, let's return to the paper airplanes. The wide-wing design had more surface area, so it produced more lift, and it stayed in the air for longer. The narrow dart had less drag, so it moved faster, yet stayed in the air for less time. When I threw harder, I increased the thrust. So even a simple paper airplane follows the same four rules as a real jet. So, the key takeaways are: airplanes fly because of four balanced forces. Lift counters weight, thrust overcomes drag, wings create lift, engines create thrust, engineers try their best to reduce drag, and flight isn't magic. It's physics and it's perfect balance. The sky isn't the limit, it's just the beginning of good engineering. Thank you for listening. I hope you enjoyed. Now try out your very own experiment and see if these forces work.